For this lesson, I just have a couple of examples to work through. It's just some more problem solving with right triangles, and you had some already in your previous lesson. The key with this is I want to make sure you understand that when you're solving problems, word problems, construct a labeled diagram as part of your solution. That will be part of your communication piece to this. So we have an underground parking lot that's constructed 8 meters below ground level. So if we have our ground level here, our parking lot would be down 8 meters from that ground level. Okay, so we'll make a right angle right there, and this distance here is 8 meters. And we need the exit ramp, so parking lot's down here, we need the exit ramp to rise at an angle of 15 degrees. So cars driving along here, there's our car. It's going to go up the ramp, and this ramp can only be 15 degrees to the horizontal so that it's safe. So how long will the ramp be to the nearest hundredth of a meter? So this is my unknown that I need to find out. I need to know how long that ramp is going to be. What horizontal, and then part B is what horizontal distance is needed for that ramp. So I could use a different letter here. Whoops, moving the whole page. Different letter here to find part B. All right, so for part A, I'm going to look at the sides that I know. I know the side that's opposite to the given angle. So that's opposite, and I want to find the hypotenuse for part A. So opposite and hypotenuse is the sine. So I can write the sine of angle A is opposite over hypotenuse, and then we're going to fill in what we know here. The sine of 15 degrees is going to equal 8.0 over x. And then we can't solve for x when it's on the bottom, so we're going to multiply both sides by that x to get it off of the bottom. It leaves you with x times the sine of 15 degrees being equal to 8.0, and then to get x by itself, I'm going to divide both sides by the sine of 15 degrees. And then x, I'll put that into the calculator. And again, my calculator, I'm going to go 8 divided by, and then 15 sine, and I have to hit equals, and that gives me 30.9 approximately. So just make sure you know how to use that calculator, and yet you are in degree mode for that. And as a final step, make sure you put a final statement on it. The ramp needs to be 30.9 meters long. So for part B, the horizontal distance now is what we need to find out. Let me just get the right tool up here, part B. There we go, part B. I need to find the y, which in terms of our 15 degrees, that one is adjacent. So adjacent, but again, I'm going to use the opposite because that was my given side. I could also use Pythagorean theorem, but I find it's a little bit more finicky in terms of I've got a few more lines in my solution there. In terms of trig ratios that use opposite and adjacent, that's the look at the tan. So the tan of angle A is going to be opposite over adjacent. And I'm going to put in what I know. Angle A is 15 degrees, and my opposite is the 8. And my adjacent I've labeled as y up above. Multiply both sides by y to get that away from the bottom, and follow that through by dividing both sides by the tan of 15 degrees. Divide both sides by the tan of 15 degrees, and that will give us our value for y. So we're going to have y being approximately equal to 8 divided by 15 tan equals, that rounds to 29.9. 29.9 meters will be that horizontal distance there. And again, follow that up with a therefore statement. All right, my next example here, which I'm just going to do on another slide. All right, we have our next example here. Sarah's looking out of her apartment window. So her apartment's here, here's her window, and she's looking to the building across the street. So let's draw a building across the street. Here it is. There's our other building across the street. Now we're going to assume that these buildings, I don't know how tall Sarah's building is, but it doesn't really matter, make a 90-degree angle with the ground. All right. Now she's looking out her window, so there's Sarah in her window. This is her horizontal line of sight, which also makes a 90-degree angle with the building across the street. The angle of elevation to the top of that building across the street, this angle upwards is 15 degrees in here. And the angle of depression to the bottom of that building is 30 degrees. So my diagram's not to scale, but you get a picture of what this kind of looks like. And the buildings are 40 meters directly across from each other. So this distance in here is 40 meters. How tall is the building across the street? Now, I just want to point out, if this is 40 meters here, it means that this is 40 meters up here as well. So let's just write that in, because then I can work with these little right angle triangles that I have up here. So let's look at the bottom right angle triangle that I'm going to highlight kind of in green here. We know one side is 40 meters, and I could figure out x. X would be this length of that triangle. So based on the 30 degrees, this is opposite. This would be hypotenuse over here, which I don't know, nor do I care, but this one, this 40 meter side is the adjacent. So if I want opposite and adjacent, I'm looking at the tan. So our tan of the 30 degrees would be opposite over the adjacent, which is 40. Now to get x by itself, it's being divided by 40. Let's undo that by multiplying both sides by 40. And then we pop that into the calculator, nice and easy. The tan of 30 degrees times 40 equals, I got about 23.1. So that piece, x, is 23.1 approximately meters. X is approximately 23.1. All right, now I am going to use the triangle above the green one to solve for y, which will be this side length. And that one's related to the 15-degree angle. That is opposite, that is opposite the 15-degree angle. And again, the 40 meters is still adjacent. So now I have the tan of 15 degrees opposite, over adjacent, look at the tan. Multiply both sides by 40 and throw that into the calculator. And that will give us a total there. So 15 tan times 40. I got about 10.7 out of that for y. Y is approximately 10.7. Collectively, x and y will make the total height of the building. So x plus y is the 23.1 plus the 10.7. Put that into the calculator, or just add that. That's going to be 33.8 meters. So therefore, the building across the street is about 33.8 meters. So again, don't forget to follow up those questions with a therefore statement, and make sure you include a diagram with your solutions.